Hello students, today we are going to study design of joints in cement concrete pavements. Various types of joints provided in the cement concrete, which are as expansion joints, contraction joint and the construction joint. Now we will study expansion joint. The purpose is to allow the expansion of pavement due to rise in temperature with respect to construction temperature. To design the joint, we find out the joint for a given joint thickness of 2.5 cm maximum as specified by Indian Road Congress. The maximum spacing between expansion joint is 140 meter. At the expansion joint, dowel are provided which develops bending, bearing and shearing stresses and help in load transfer. The filler provided at the expansion joint are assumed to be compressed by 50% of its thickness during expansion, hence the gap of the joint should be twice the expansion in the concrete, which is shown here. Filler has the original thickness of delta, but due to expansion of slab, it gets compressed to maximum of delta by 2. So L alpha del T will be equals to delta by 2. So L will be equals to delta upon 2 alpha del T, where L is the maximum spacing between expansion joint, delta is the gap of expansion joint, alpha equals to coefficient of thermal expansion and del T is the rise in temperature. Now the next type of joint is the contraction joint. It is provided to control crack due to shrinkage and moisture variation. To regulate the crack, that is to ensure that crack forms at predetermined location, slab is weakened at certain intervals. These locations are called contraction joint, which is shown here. Now spacing of contraction joint. During initial curing periods, shrinkage occurs in the concrete, and if the shrinkage is resisted, tensile stress develops in the concrete slab. Fall of temperature will also develop the tensile stress in the concrete slab. When no reinforcement has been provided in the concrete slab, length of contraction joint is calculated as follows. That is, L is equals to 2 sigma upon small f into gamma of concrete, where sigma is the permissible tensile stress in concrete, f is the coefficient of friction between concrete and base, L is the spacing between contraction joint and gamma concrete is the unit weight of concrete. When reinforcement is not provided, the maximum spacing between contraction joint is taken as 4.5 meter. Now one note is written here, that is, when coefficient of friction is 1.5, gamma of concrete is 24 kN per meter cube. If sigma value is not given, then it is taken as 0.8 kg per centimeter square. When reinforcement is provided in the slab, it is assumed that all tension is taken by reinforcing steel only. Therefore, sigma st into ast is equals to b into L by 2 into h into gamma of concrete into coefficient of friction. So, L will be equals to 2 sigma st into ast upon b into h into gamma concrete into coefficient of friction. Now, the next joint is the longitudinal joint. Longitudinal joints are provided along the length of pavement. It reduces the warping stress, the normal width of slab and provided longitudinal joint. We generally provide tie bars at the longitudinal joint. The tie bar ensures that the two adjacent slabs remains firmly together. Tie bars are not designed as load transfer device but ensures that the two slabs remains firmly together. Load is actually transferred to the adjacent slab due to aggregate interlock. Tie bars are bounded with concrete and we mostly used deformed bar of size approximately 10 mm diameter. Their length is smaller than the length of dowel bar. They are designed to withstand tensile stresses generated due to frictional forces between slab and the soil below. Assuming all forces in unit length of slab to be taken by the tie bars, we have longitudinal joints like this. Now we have ast into sigma st equals to L into b into h into gamma of concrete into f, from which ast will be equals to b into h into coefficient of friction into gamma of concrete upon sigma st, where ast is the area of steel per unit length, sigma st is the permissible tensile stress in the steel, that is 1400 kg per centimeter square. F is the coefficient of friction, which will be equals to 1.5. Gamma of concrete equals to 24 kN per meter cube. The length of the tie bar is decided on the basis of development length. The length would be equals to 2 times of development length. So here length will be equals to 2L. Thus, n into pi into phi into LD into tau BD is equals to n into pi into phi square upon 4 into sigma st. So, development length will be equals to sigma st into phi upon 4 tau BD. So, the length of tie bar will be equals to sigma st into phi upon 2 tau BD, where n is the number of bars, phi is the diameter of bar, LD is the development length, tau BD is the bond stress between steel bar and concrete, sigma st is the permissible tensile stress in steel. That is all about the design of joints in cement concrete pavement. Thank you very much, students.